Hey all you cool cats and kittens, it's Carol here. Just kidding, it's Professor Gray, but now you guys know what I've been watching when I've not been making lecture videos. And if you don't know what I'm talking about, well, you better get Netflixing. Okay, so this time we're going to talk about naming acids. So not only do you guys need to know the rules for naming ionic compounds and covalent compounds, but you need to know how to name acids. And the acids have two different naming rule sets. And the first one is the acids that do not contain oxygen. So if you look down at the bottom, we've got HCl and HF. And hopefully most of you will know that HCl, when it's behaving like an acid, when it's dissolved in water, it is called hydrochloric acid. Now, how did we get that name? Well, the first rule says that you're going to begin the name with hydro. And how do you know that this is even an acid? Well, when we get to chapter 9, we'll talk about acids and bases a whole lot more. But for now, acids are compounds that can release a hydrogen when they're dissolved in water, so when they're in solution. So if you look at a compound and it has a hydrogen written at the front or the left of the formula, there's a chance that you've got an acid there. So if it doesn't have an oxygen in the formula, you're going to start the name with hydro. So what we do after that is we name the anion, but we change the ending to ic. So we can think of HCl as H plus and Cl minus because those are the ions that it's going to split up into when we dissolve it in water. So the anion right here is chloride. So we start the name with hydro, and then we change chloride to chloric acid. So B and C says name the anion, which would be chloride, but change its ending to ic, so that's chloric. And then C says slap acid on the end of it. So that's how we get hydrochloric acid. Now, if Cl is chlorine and F is fluorine and HCl is hydrochloric acid, what do you think HF is? Well, if we look at it and go, oh, it's probably an acid, and we begin the name with hydro because there's no oxygens. And we know that when F is in a compound, it's not fluorine, it's fluoride. We know that we change the ending to ic from ide, so we have fluoric. And we slap acid on the end, so we have hydrofluoric acid. And it makes sense that if HCl is hydrochloric acid, that HF would be hydrofluoric acid. Okay, so that brings us to acids that do contain oxygen. So if you have an acid and it doesn't have an oxygen in it, it does have an oxygen in it, we are not going to put hydro on the front. So if we have H2SO4, we can look at that one and go, okay, it's got a couple of hydrogens written on the front. So usually that indicates that that's an acid. And that has oxygens in it. So we're not going to start that name with hydro. And if we do know the name of that, which is sulfuric acid, we can see that that fits. It's not hydrosulfuric acid, it's just sulfuric acid, and that's because it contains oxygens. So we come to B, and it says begin the name with the anion. Well, the anion in H2SO4 is the polyatomic ion sulfate, and that is SO4, and that's -2 if we remember our polyatomic ions. That's sulfate, and that one is right here. Okay, so begin the name with the anion, so sulfate, and C says if the anion has the ending 8, which we do right here, we're gonna change this to ic acid. So that's gonna change it to what we would think would be sulfic acid, but no, it's sulfuric acid. Sorry about that little change there. I should have started with an easier one. That's kind of an anomaly there, but sulfuric acid. If the anion has the ending "ite," we want to change the ending to "us" acid. So if we had H2SO3, we would go through the same process again and go, okay, we've got some hydrogens on the front there, which Professor Gray just said probably indicates that we've got an acid. And what we want to do is identify the anion. And the anion should be a little bit obvious to you guys because we just did polyatomic acids and we just did one that looks very, very similar to sulfate. So this right here, if we write it in its ionic form, oops, that's a 3. It's the polyatomic ion sulfite. And so what we want to do is go, okay, we don't have C, we have D. The anion ends in "ite," and we want to change the ending to "us" acid. So it would seem that we would change the ending from "ite," so sulfite, to sulfus acid, but again, bad me, I did another one of those that's kind of an anomaly, but you got it. This one is sulfurous acid. Okay, so some more examples here at the bottom, and I'm going to start with one of them in the middle, HClO3. So if you remember this set right here, we talked about how the ones in the middle, these two, have the ending "ite" and "ate." So this one right here would be the "ate" ending, and this one would be the "ite" ending, because the "ate" ending indicates that we have more oxygens, and the "ite" ending means that we have fewer oxygens. And we can see those anions right here. So we've got chlorate and chlorite. And what happens when those anions are in an acid? How do we name them? Well, the first one, we change chlorate to ic, and we slap acid on the end. So we have chloric acid. And for this one, the anion ClO2 minus is chlorite. So we change that to us and we put acid on the end. So HClO3 is chloric acid and HClO2 is chlorous acid. So what happens when we have more oxygens than chloric acid has, and what happens when we have fewer oxygens than chlorous acid has? Well, we don't change the endings at all. All we do is we add on that prefix that we had here and here. So we still have a chloric acid, but we put the prefix on the front, and now we have perchloric acid. So that one is that one right there, okay? So this one on the bottom right here, The anion is hypochlorite. So that means then this one is hypochlorous acid. And there should be a space right there. So we go from hypochlorite to hypochlorous acid because we have the ite ending here, and we just take the prefix along with us. So that's how we name that set. Now let's go ahead and do some problems. So the very first one says HBr, and that's a gas. And then number 2 says HBr, and in parentheses it has AQ. Now AQ means aqueous, or some people say it aqueous, and that means it's dissolved in water. And HBr needs to be dissolved in water to have its acid behavior. So the very first one, HBr, just as its gas, we're just going to name it with its compound name. So this one right here is going to be hydrogen bromide. And then number 2 has the AQ in parentheses. So that's telling you this is the acid version. So we look at it and we go, okay, this is an acid because she just told us an acid, and we're in the acid section, so we have to name it. And it does not have oxygens. So when it does not have oxygens, I want to start the name with hydro. So I have, oops, my writing isn't that great today. We have hydro, and bromide turns into bromic acid. So we have hydrobromic acid. And there's a space right there. Now, if you remember, HCl was hydrochloric acid and HF is hydrofluoric acid, so it should make sense that HBr is hydrobromic acid. Now, number 3. Number 3, we've got HNO2. That looks like an acid. In parentheses is AQ, so we're going to go with acid naming here. And it has oxygens in it. So if it has oxygens, we know that we're not going to start with hydro. We're just going to find the anion there and change its name to having an acid on the end. So we have to identify which polyatomic ion that is. And if we look on our polyatomic ion sheet, we can see that NO2 is nitrite. So we've got an ite ending here. So this one is going to be nitrous acid because NO2 minus is nitrite, so we've got the ite ending. And the rules say that if you have an ite ending, you're going to change this ending to us acid when we have this anion forming an acid. Okay, so that brings us to HNO3. So if NO2 was nitrite, then NO3 is going to be what? Nitrate. That's right. Okay, so this one is nitrate. We have the ate ending for this anion. We have an acid that has oxygens. So we don't start the name with hydro. So this one is nitric acid. Because if we have the ate ending, the rules say that we change it to ic acid for the acid form. Okay, number 5, we have HI. So we have HI, which looks like an acid, and it has AQ in parentheses, so it's behaving as an acid, so we're going to name it as an acid, and then we have to pick which group of rules we choose for naming this acid, and it has no oxygen. And if it does not have an oxygen, we said that we're going to start the name with hydro. So we have hydro something, and the anion is iodide. So we want to take the "ide" off the end, and we want to add ic acid. So this is hydroiodic acid. Just like HCl was hydrochloric acid, HF was hydrofluoric acid, HBr was hydrobromic acid, HI is hydroiodic acid. Okay, so that brings us to number 6, which is HI in the gas form. So it's not dissolved in water. So we just want to name that with a regular compound name. And that one would be hydrogen iodide. Just like HBr in the gas form is hydrogen bromide. Okay, number 7. Number 7, we see that we've got oxygens in that acid. So we're not going to start with hydro. And then we want to identify the anion, which is CO3 right there. So we're going to pop on over to our polyatomic ion list, which is right here. And we're going to look for a CO3. And aha, there it is. That is carbonate. So again, no hydro on the front. And it has an 8 ending. So instead of carbonate, we chop the 8 off and we put on ic acid. So we have carbonic acid right here. Number 8. Number 8, we've got oxygens there. So we want to identify the anion. And we want to not have hydro on the front, but let's figure out whether we have ic acid or us acid on the end. So let's look for PO4. So PO4 is right here. So we've got phosphate. So we've got an 8 ending again. So it would seem that we would call this phosphic acid, but that's another one of those anomalies like sulfuric acid. This is phosphoric acid. Sorry about that, you guys, but that's just how it goes. Okay, so phosphoric acid. Now, if PO4 is phosphate, then PO3 would be what? That would be phosphite, because we have fewer oxygens in phosphite than we do in phosphate, and that's how the rules work with oxyanions. So if H3PO4 is phosphoric acid, then H3PO3 would be phosphorus acid. And again, that's because the rules say if you have an "ite" ending, you change the ending in the acid to "us" acid. So we have phosphorus acid because this came from phosphite. Okay, number 10, we have HCN. And HCN looks like kind of a funky one. Like, we've done hydrochloric acid, hydrobromic acid, hydrofluoric acid, hydroiodic acid, but this one looks a little bit different. But also looking at it, we see that we don't have any oxygens. And if you don't have any oxygens, you don't start with hydro. So we know that. We're not going to start with hydro. So let's identify the anion. And the anion is Cn. So that's a polyatomic ion. There's more than one atom there making up that ion. So the thing is, we have to identify which one it is. So we pull out our handy dandy polyatomic ion sheet and we look for an OH. And we find OH right here. That's hydroxide. So, oh, wait. We're not looking for OH. Oops, my bad. We're looking for CN, aren't we? Okay. Sorry, I confused you guys. I can do that from the classroom and I can do that from home too. Okay, so we've got cyanide there. So Cn minus is equal to cyanide. So we've got the "ide" ending there. So going back to naming acids that do not contain oxygen, you guys can see that we start with hydro and we change the ending to "ic" acid. So we're going to have hydro, cyanic acid, hydrocyanic acid. Now we don't want to confuse that with cyanic acid because cyanic acid is a totally different acid. Cyanic acid is HOCN. So you guys can see that when you have an oxygen there, there's no hydro on the front. And those are two different acids. So if you write hydro and you don't mean hydro, you're going to be saying something different. Okay, so that is the acid lesson. And the next thing we have on the list is molecular structures. So I'm going to talk about molecular structures and Lewis structures in the next lecture. So stay tuned.